So welcome to dependency mapping. What we're going to do in this video is learn a very useful technique for analyzing our C++ and header files and finding out what depends on what. So let's dive in and make that happen. So let's just have a quick recap of what we've done lately. We've refactored our aiming component in order to make it completely independent, so it could sit on the tank independently of anything else. Basically, it could be added and removed from the tank at will, except from, of course, we need to initialize it here. I'm just going to remove this print string, by the way. We don't need these print strings. So whenever I see these logs, I'm just going to get rid of them. Also, by the way, my tabs are still opening in the wrong place. I want them opening here in the main window. The way to make that change stick is to go to Edit and Editor Preferences. Under Appearance, you go Asset Editor Open Location. Let's make that the main window, but this time let's click Set as Default. Yes, we want to update the default settings, and yes, we want to write to the settings file. It may impact other developers. Okay, what you'll see in source control is that we have a new file here, which is the default editor per project user settings.ini. What a mouthful. Anyway, we refactored our aiming component. The purpose was that we then have this independent aiming component that can be added or removed from the tank at will. We then went on and talked about the constructor and begin play timing, and we did some timing decoupling of our architecture. We prevented the startup from being dependent on the order that things happen in. So more specifically, what we did, if we remember, is we went into, where's the tank player controller? Our tank player controller had this event found aiming component reference, which goes ahead and only creates the crosshair when the aiming component is found, if you remember, and then we set this blueprint variable. While we're on here, if you don't like these lines doing this crossing through, you can add something called a reroute node, which is at the bottom of your blueprint menu. You can then drag into that and then out of that, and what you get is you get a simpler, cleaner line. I would only do this once your blueprint design has been settled and simplified, because otherwise you create constraints that mean you can't move things around so easily. Anyway, that's where we got to with that, and then we use the ensure assertion to catch things like null pointer errors in a much more helpful way. But at this stage in the project, we have a horrible problem looming, which is that our architecture isn't very nice. And how do we even know our architecture is not very nice? Well, the symptom is that we've still got problems. Not everything is working. We've got some null pointers, etc. Now, we can go through and sort those out, but I want to show you a formal way of mapping your architecture. And whenever you feel that your project's getting a little bit out of hand, this is what we need to do. What I want you to do is to go to the private folder and start with the projectile.cpp, and note that yes, it includes the battle tank, and yes, it includes the projectile header, but it doesn't include anything else. Everything includes battle tank. So everything depends on battletank.h, because this is the battle tank project. That's fine. But projectile depends on nothing else. So I'm going to start drawing a diagram only about the aiming part of the architecture. And I'm going to start there with the projectile class, saying it doesn't depend on anything. So let me continue. The tank. The tank depends on all this stuff in the middle. Not the battle tank, not the tank itself, obviously, but it does depend on the barrel, the projectile, the aiming, and the movement components. Let's look at that on a diagram. The tank depends on the barrel, the projectile, the aiming, and I've left out the tank movement component for clarity, as I said. Okay, I'm going to do one more, and then I'm going to leave it to you to do this dependency mapping, which you literally do through these CPP files like this. Okay, so the tank AI controller CPP, what does that depend on? Depends on the tank. Okay, so what you do is you come in and you draw the AI controller, and you say it depends on the tank. Now, look, I don't care how your diagram is laid down. Mathematically, this thing is called a graph, and all I care about is how it's connected. There's an infinite number of ways you could draw this. But I want you to carry on this process and finish off this diagram by working down the CPP files. I'm not going to put a challenge slide up because it would mess up the transition of this nice diagram, but I want you to pause the video and finish this dependency diagram now. It's really important you spend the time thinking about this. Okay, so how have you got on? I'm just going to carry on. It's a very simple task, actually, but it brings up some really interesting questions. You'll just be able to see that this is not right. So, the tank aiming component depends on the barrel and the turret. Tank aiming component depends on, which means it imports the code of, that's what I mean by depends on, the barrel and the turret. Okay. What does the barrel depend on? Nothing, because it's just two. What does the movement component depend on? We don't care, because we're not dealing with that at the moment. What does the player controller depend on? The aiming component and the tank. Wow. Player controller depends on the aiming component and the tank. How did you guys let me get it into this state? I'm surprised nobody noticed me sneaking you into this horrible corner. The track and the turret depend on nothing. So look, just take a look at that. What does it look like to you? Well, it may seem acceptable to you, but it certainly isn't to me. This is what we call spaghetti. This is not a good architecture. How do we know more formally it's not a good architecture? We have loops. Well, we at least have diamonds here. So the turret, where's a diamond? A diamond here with the barrel and the player controller. So what you've got is you've got two ways of going from the player controller down to the barrel. I don't like that. That is pretty minging. We have two things referencing the barrel. That's not too bad, but it's not necessary here. We don't need both the tank and the aiming component to know about the barrel. In fact, the tank doesn't need to know about the barrel. If you remember, I even started to hint at that in the tank header file. I said down here that we could remove the barrel pointer in the future. So we're starting to get the idea. But look, that architecture sucks. It just isn't good. So what are we going to do about it? What target architecture do we want? Well, what I want to head towards is just that. Now let's flick between them a couple of times. I know they move slightly, but the AI controller and the player controller at the top here are in the same place, there. The tank has disappeared. We actually don't need to send everything through the tank. We could, in this architecture, put the tank where I'm indicating on the diagram, above the aiming component. And we could send all these commands through the tank if we needed to. You would tend to only do that if this code that's calling the tank is not refactorable for whatever reason. But as we can refactor this code, we can repoint this to call straight to the aiming component. Okay, so we don't have a tank at all. The aiming component is still here, but it's just in the middle now. And then projectile, barrel, and turret are at the bottom, but look how simple and clean this is. For aiming, we're talking about aiming here. For aiming, the AI controller and the player controller just talk straight to the aiming component. The aiming component needs the projectile, the barrel, and the turret to do its job. Simple. And it's not that hard for us to get to that architecture. By the way, while we're there, let's just look at the movement component architecture. It's pretty much like this as we are. So firstly, what we have is input. It's not really a C++ class in the same way. So I'll put it green and also put a dotted line to indicate that it's not the same type of dependency. But of course, if you go to your project and you go to the tank blueprint, then we have this dependency here where input binding uses the tank movement component. So I wanted to bring that to the surface. We also have the AI controller somewhat implicitly depending on the movement component via the pathfinding logic. You remember how that worked? If we look at the tank AI controller CPP, it makes a call into move to actor. The pathfinding logic does stuff with that, and eventually in the movement component, we end up in request direct move. So we do have a dependency there. I think because we have that dependency between the AI controller and the pathfinding, I'm going to pop it at the top of the file here. So this is saying that the AI controller has a dependency here. I'm going to write depends on movement component via pathfinding system. I wrote it a few seconds ago offline, so you don't just see me typing it. So that's up in the header so that we can shake out the dependencies. We could do the same thing with the input, although there's nowhere to write that. So I can't actually comment on the input. It's going to be pretty obvious what input depends on in the blueprints. It's not quite as easy to search for. So finally, the movement component depends on tracks, right? So if we go to the tank movement component, it should depend on tracks. So that's effectively our movement architecture. All we need to do is to get to that architecture is to just go into the tank CPP and remove the tank movement component header file because we're not actually using that. If you're not sure, then what you do is you do a search for utank movement component in this file. Anyway, it's already not showing up. The other thing we need to do is to go to the tank header file and remove the utank movement component reference there. And I think that's the majority of it, actually. It's just getting rid of those things. Here, yes. The tank movement component pointer in the tank header file. We don't need that either. So we flushed all the movement component stuff out of the tank. We still have this architecture. There is no tank featuring there. There is no tank featuring here. And what we're going to do in the next video is to focus on getting to this architecture. It's going to be a big refactor video, so make sure that you've got 20 minutes at least to watch the video and more time to actually do the challenge of the refactor yourself. So it's going to be fun. It's going to be a much nicer system for it. Just going to pop back into Unreal and make sure that we compiled. If you compile a second time, of course, it's much quicker. Just going to make sure that things work, i.e. that I can move. I just turn my controller on, and that they can move. Yep, so movement still works. So in good shape, and I'll see you in the next video.